Hello physics students. Once again we have a graph that we have to analyze, so you know the drill. Take time, pause the video. As you can see, I've changed this from a position graph to a velocity graph because I crossed that out and said it's velocity now. So pause the video. Okay, I hope you paused the video. So now let's take a moment and see what is going on here. So we have our velocity in meters per second for our y-axis, and our x-axis is the time. So that means instead of our slope being velocity, our slope is now the acceleration, which means we start off, we are going forward, we are accelerating, we keep accelerating until we get to here at 6 seconds. Then we decide we want to start slowing down until we almost get back to our original speed of 0. But instead we stop at 1 meters per second. Still going forward. Okay, so here we have it. So a question that would possibly be asked about it is, what is our acceleration at 1 second? So to do this, we see that this is a fairly consistent slope. So we look at point 0 and point 2 and 2. So we use that to calculate our slope. Our slope equation is rise over run. So we have a rise of 2 and a run of 2, which gives us our acceleration of 1 meter per second. And now that is our acceleration. We see here our acceleration is positive and our velocity is also positive, which means we are speeding up going forward. And then we get to here where our acceleration becomes 0 because the slope is 0 at this point, because it goes from positive to negative and therefore must pass through 0. And then after that we are still in the positive quadrant for velocity, but our slope is negative, which means we are decelerating or accelerating in the negative direction, which means it is slowing down until we get to 1 meters per second, and after that we don't know what happens. I hope that was useful. Just another example.